What if I told you that you are already dead? That right now, as you watch this video, you are also taking your first breath. And at the same time, you have been buried for 1,000 years. We believe time flows like a river, from the past through the present into the future. But modern physics suggests this is a persistent illusion. In reality, the universe might be a frozen block of ice where the dinosaurs are still alive and the end of the world has already happened. Everything exists at once, forever. This is the story of eternity. And to understand it, we first need to learn how to count it. Splex. To witness this firsthand, you must rise at dawn, trek for half a day to a mountaintop, and then venture deep inside it. There, hidden within layers of rock, lies a colossal mechanical clock. Every 1,000 years, it marks the occasion with a unique chime from a cascade of musical tubes. The entire mechanism synchronizes itself, correcting for the Earth's movement and other nuances, all without electricity, just gears, weights, and levers. The clock is powered by the sun's heat acting on a graphite cylinder and the work of a multi-ton counterweight. It is designed to operate for 10,000 years, even if no human ever sets foot there again. This is how mathematician and engineer Danny Hillis, the creator of some of the fastest computers of his era, devised what he calls the world's slowest computer. His goal was to encourage our civilization to contemplate itself and its actions on a vastly different timescale. Humanity possesses plenty of artifacts that direct our thoughts and imagination into the distant past, like the Great Pyramids. However, we lack artifacts that direct our minds beyond the horizon, millennia, into the future. And when we speak of eternity, we think about what will remain after us, and for how long. We ponder death and the possible rebirth of the universe. Are we truly imagining eternity, or just a very, very long but finite stretch of time? Is our brain even capable of conceiving eternity? What you see now is what turned out to be the longest period of time ever calculated by a physicist in a scientific study. The author was investigating information loss in black holes, and for this, needed to compute a turning point in the universe's future, the Poincaré recurrence time. This, of course, isn't about the great French mathematician being resurrected, but rather about the possibility of the universe, at a certain moment, returning to the state it was in originally. Here's how it works. Imagine you have cards with letters of the alphabet. You draw as many cards from the deck as there are letters in your name. Initially, it's gibberish, but if you repeat this process over and over for a very, very long time, you will eventually, by chance, spell out your name. This is bound to happen under one condition. The number of cards is not infinite. Now, replace the cards with atoms. At first, they were in one small cluster, but over time they dispersed and filled all of space. This space is finite, even if it's our universe. Atoms can no longer be added to it from nowhere, from nothing. Well, let's assume they can't cross over from a neighboring universe. For the universe, a moment will inevitably come when the atoms that were initially in a cluster and then scattered will find themselves in a cluster once again. How much time does this take? An eternity? As it turns out, not at all. In that paper, the longest calculated period was for a universe in just one of the cosmological models. For our own universe, the Poincaré recurrence time is calculated by the author to arrive much sooner, because the universe can only exist in a finite number of quantum states. So, we haven't even come close to some limit for our minds beyond which eternity would begin. But what if we could simply calculate it? Would we need a number larger than our universe can contain? There is a very simple game called the tree game. Its purpose is to grow a forest by combining different seeds. The trees can be represented by simple circles of different colors. These are the seeds. Connected by lines, these are the branches. The rules are straightforward. The first tree can have only one seed. The second, no more than two. and so on. The forest dies when you construct a tree that contains one of the previous ones. In simple terms, you cannot repeat combinations of circles and lines that have already been used. The great eccentric and mathematician Paul Erdos used to call children epsilons, meaning infinitely small quantities. He could show up at your home unannounced and go to sleep in your bed, but he always came with interesting problems. So, he asked another friend, can the tree game last forever, meaning infinitely long? And now, more than half a century later, a mathematician in his doctoral dissertation managed to prove that the game cannot last forever. But then, how long can it last? That depends on how many types of seeds you use. With one type of seed, the forest can't have more than one tree. With two types, a maximum of 3 trees. But when we add a third type of seed, the game explodes. The maximum number of trees becomes so enormous that it seems impossible to even imagine. It can be described like this, and it is known to mathematicians, but writing it out in full is impossible. There isn't enough space in the entire universe. If you've heard of the largest number, Graham's number, it's barely more than 1 in comparison to our number, a mere trifle. Let's play a quick game. For this, we'll make each move, that is, draw 1 tree in a fraction of a second, 10 to the power of -44. This is Planck time, the shortest interval of time that has physical meaning. Beyond this, our formulas cease to work. To even grasp how small this unit is, consider this. More Planck times pass in one of our familiar seconds than familiar seconds have passed since the Big Bang until today, until this very moment you are watching this video. And so, we draw 1 such tree every infinitesimal fraction of a second. As mathematician Antonio Padilla writes, in a year we would produce more than 1 trillion trees. But this is only the beginning. We play for our entire lives, and then, let's say, we are replaced by intelligent machines of the future with digital duplicates of our personalities and memories. 300 million years pass. Earth's continents have merged into a single supercontinent. The sun has become noticeably brighter. Our AI clones continue to play uninterruptedly at the same frantic pace. 600 million years pass. The bright sun disrupts Earth's carbon cycle. Trees and forests can no longer grow. The oxygen level drops. 800 million years pass. All complex life forms are destroyed, except for 2 steadfast AIs who continue to make moves in the tree game. Billions of years go by. The Milky Way and Andromeda galaxies collide. The sun exhausts its fuel and turns into a red giant. It is about to engulf the Earth. The AI clones do not get distracted, but evacuate. After a quadrillion years, the sun no longer shines. The 2 robots are powered by some more advanced technology. Between 10 to the 40th power years and a Google years, the era of black hole dominance begins. The game continues. During this time, all matter is swallowed by black holes that have filled the universe. They later evaporate, leaving a cold and empty universe. And the game, powered by the remaining photons, continues. Its completion is still very far off. But when 10 to the power of 10 to the power of 122 years have passed, the Poincaré recurrence time arrives. The universe, which theoretically has only a finite number of possible quantum states, effectively reboots and returns to the state from which it began, preventing the 2 eternity-ready AIs with our feelings and memories from finishing their game. But if they could exist outside of time, that is, where counting it is meaningless, but counting the moves of our game is still very important, they would one day finish the game, because while it has an unimaginably large number of moves, it is still finite, and this has been proven mathematically. But what if the cycle continues? The universe evolves again from a point, as it has done before, and so on to its limit, and then collapses again, and then starts over. Isn't this infinite repetition in a circle infinity itself? And you know, the more data we've gathered in recent years, the more strength a previously dubious and largely dismissed theory is gaining: cyclic cosmology. According to it, black holes should remain from the previous cycle, albeit not in their original form. Then, right from the beginning of the universe's expansion, these cosmological veterans, as academician Zeldovich writes, would serve as seeds for the growth of the first galaxies and the very early appearance of modern-looking structures. So large and complex, they would have formed prematurely within a few million years of what we call the Big Bang. And what do we see in the latest, deepest images in history from the James Webb Space Telescope? It seems to be exactly that. It's not certain yet, but it's certainly not something that fits well with our more conventional theories of cosmic evolution. The percentage of spherical and spiral galaxies does not decrease with distance, as data from the Hubble telescope suggested, which simply couldn't distinguish the shapes of distant galaxies. Webb has seen many massive, modern-looking galaxies in the early stages of the universe's expansion. These are magnitudes for our consciousness. What if eternity isn't about time, no matter how much of it there is, but about its absence? And to conceive of eternity, we need to somehow get rid of time in our thought process. And it seems physicists have succeeded in this experimentally. In this experiment, physicists used a somewhat forgotten paradox, long resolved by mathematicians, but which previously seemed to have little connection to our physical reality. Look here. You kick a ball, but you get distracted. You look again, and the ball is in a different spot and is no longer moving. We didn't see the movement, but we know it happened. Now, let's watch as closely as possible without looking away. That is, we should see the ball travel from one point to another. But there's a problem. As soon as we start watching too closely, it turns out that at any and every moment in time, the ball is at some single point, and only there. Not for the tiniest fraction of a second is there a moment when the ball is between points, moving from one to another. This means it is always in a state of rest, and the motion we so hope to see is a perceptual error. It appears to us because of a blurred image, the low resolution of our consciousness. Just as we see beautiful, varied images on our screens instead of meaningless dots, a multitude of separate still pictures, which is essentially what you are looking at right now, appear as moving objects. Only we're not talking about a recording, an imprint, but about the very fabric of reality. To perceive it directly, it turns out that right here and now, you and I are missing something fundamental. Eternity eludes us because we do not distinguish the pixels of time. But if such an eternity is real, it doesn't just mean that time doesn't exist. It means that all, absolutely all, events in the universe exist at once. Not right now, no, because there is no flow of time. They exist always. Here you are closing YouTube because you've had enough for today. And here you are being born. And here, the dinosaurs are alive and well. And here is the end of the universe. This is not past, present, and future. These conditional boundaries do not exist in eternity. It all happens at once and always. Then why don't we see all of this? Perhaps because we, like everything else, like that ball, are always at some single point, and only there. We who are just being born, and we who are paying off a mortgage. We cannot break out of our points, stand up and walk around as if in a library between bookshelves, and look at our different selves, peek between the rows of events and see them from the outside, and maybe even trace entire plot lines. If this all sounds like nonsense to you, well, such an eternity was achieved by physicists in a fairly simple experiment. And what's worse, it can be derived without critical contradictions from the most successful and confirmed modern theory describing the nature and structure of reality. In the experiment, instead of a ball, there was an unstable quantum system, cooled sodium atoms trapped in a standing wave of light, which serves as a series of wells for them. They don't have enough energy of their own to escape, to jump out of these wells, and there's nowhere to borrow it from. But if there were some way to seep through the barrier, why not? This phenomenon is called quantum tunneling. True, they don't escape from the wave entirely, but only from their current well to an adjacent one. But for the whole system, this is already decay. Eventually, the atoms will sooner or later spread out into different wells, and almost nothing will remain in common between them. Decay occurs because particles cannot remain in one state forever. And what state they are in at any given moment, we never know, just like with Schrödinger's cat. Is it alive or dead until we open the box? Until we look into the well, that is, perform a measurement? Is the particle still there or is it gone? When we observe, we are, in a way, stopping time for a moment, forcing the particle to freeze in a certain state. If that's the case, what's stopping us from doing this not for a moment, but constantly? What if we did it continuously, like with that ball, every single instant? Then Schrödinger's cat would never die, and the particle would never change its state and would always be in an unchanging state. Like that ball, it would never move, as if it ceased to exist in time. In the experiment, the system continued to decay, but much more slowly. And the problem wasn't that the laws of nature themselves were interfering or that physicists were hitting some fundamental limitation. No, it was simply that they were conducting measurements every microsecond. A paltry microsecond. That's a fraction of our familiar second with 6 zeros after the decimal point, just so you understand. Scientists jokingly call this effect slowing down electrons. These advanced systems are capable today of slicing events into attoseconds. Let's say Flash from the comics runs at nearly the speed of light. In a microsecond, he would cover about 300 meters, but in an attosecond, no more than the size of a single hydrogen atom. And this limit of our ability to delve into the fabric of time is merely technical, and therefore, essentially temporary. What if we reach the elementary particle, in quotes of course, of time itself? What awaits us where physicists today speak not of types of seconds, but of the limit of our understanding of time and space, of Planck time? What if, somewhere there, are the indivisible points where there is no instant between them, let's say quanta of time? In physics, this concept is called discrete time. If time is structured this way, it would mean that somewhere out there, the frames of reality are changing one after another. The universe is, in a sense, jumping from one moment to the next, bypassing intermediate states. Discrete time sometimes appears in the formulas of physicists working on quantum gravity. But there's a problem here related to our consciousness. When I talk about discrete time, my brain, and most likely yours too, continues to follow a mental arrow of time, right? The imagination is led from one frame, event, or point to the next, along an imaginary line, most likely from left to right or somewhere forward. Each step we take is possible because we take it after the previous one. This is what is sometimes called the causal structure of reality in physics, a direct connection of events. Something happened only because something happened before it. If the universe is structured this way, and let's assume for now that it isn't necessarily so, it means that everything has a cause. So, hypothetically, we can trace a chain along this imaginary timeline from our breath right now back to what we call the Big Bang, the moment when, according to modern theories, not just everything began, but space-time itself arose. But what was the cause of the beginning? After all, there was something before the beginning, right? Why did we stop at the point where the Big Bang began? Why don't we take one more step back in this chain? The fact is, as soon as we try, from the height of modern scientific achievements, we fall into an abyss, like down a rabbit hole into complete madness, where our formulas go crazy, where all the laws of nature known to us break down and cease to work or even exist. We find ourselves at a point where our mathematics stops working. We call this point a singularity. So, suddenly, we begin to lose in our understanding of the universe as soon as we even entertain the possibility of eternity. But why? And what is completely incomprehensible is how it turns out that by killing infinity, we have made eternity one of the foundations of modern scientific ideas about the cosmos. Isn't that madness? To try to understand, let's transport ourselves to a rainy October day when an odd man was found unconscious. In such foul weather, the motionless body on the side of the road attracted the attention of even the few and indifferent passers-by. The man, covered in mud, was muttering incoherently. When they turned him over, they were horrified. It was the famous writer Edgar Allan Poe, author of very popular spooky and intricate stories. He had disappeared without a trace a few days earlier, healthy, and without any warning. They searched for relatives, but in vain. He was wearing someone else's ill-fitting clothes, and his mind was addled. What had happened? He was taken to a hospital. Occasionally, Poe would regain consciousness and repeat something, but only one word could be made out: Reynolds. He never had an acquaintance with that name, and to this day, researchers do not understand what it meant. In the morning, when his heart gave out, just before his death, according to the doctor, he unexpectedly uttered, "Lord, help my poor soul." It's possible he went mad. Perhaps it was a brain tumor or a virus. But the main thing that this grief-stricken man, who had recently lost a loved one, lived for was a rebellion against the eternity and immutability dictated by the science of his time. The last thing the writer managed to publish before this was an unexpected and very strange book for a poet, a book on astronomy. In it, summarizing the very latest scientific knowledge, he non-trivially deduced that the universe is finite in time and is changing, and this can give rise to other universes with which ours does not interact in any way. For physicists of that time, this was an absurdity, the incoherent ravings of an unfortunate man in a fever. It would become a revelation, no longer intuitive and mystical, but scientific, a century and a half later. Only at the end of the 20th century would all the elements of a scientific, physical picture of the world be in place. Theories, calculations, observational data with which Poe's insights would cease to seem like incoherent ramblings and would become his victory. The thing is, in his time, it was believed that the universe was infinitely uniform and static. If we know where the moon is now, we can say with precision where it was 1 billion years ago and where it will be in 1 billion years. The universe, to a teeth-grinding degree, resembled an eternal clock in which everything worked smoothly and predictably, without beginning or end. But this would mean that no matter which point in the sky you look at, sooner or later, at some distance from us, there would necessarily be a star. And that means the entire sky would be flooded with infinite light, which does not happen. And Poe, not a scientist, gives the first convincing explanation for what was called Olbers's paradox. In fact, Poe constructs an entire cosmology that gives the reader an answer to this and many other questions. In it, the universe is not infinite and is constantly changing, which was unthinkable at the time. It's no coincidence that the book was soon banned in the USA and later in Tsarist Russia, because Poe claims that not just everything within the universe changes, which is obvious, but the universe itself, time and space itself. Thus, Poe deduces that the universe was not always as it is and began at a single point. Matter and energy were one. This would later be Einstein and the theory of relativity. Later would come one of the fathers of the Big Bang theory, the Catholic abbot and mathematician Georges Lemaitre, with his primordial atom or cosmic egg. And this means that space-time itself had a beginning. But what was there before this beginning? Poe predictably says, the eternal God. Today, in the most accepted and developed theories, we say singularity, a point at which our physics, which explains processes so well everywhere else and knows how to predict them, breaks down and the formulas go crazy. That is, the very question, what was before, suddenly loses its meaning at this point of the beginning of beginnings. Describing the cosmological beginning of the universe from a single point, Poe, without suspecting quantum mechanics and entropy, shows a dynamic, finite, and unpredictable universe. The universe that we know and understand so little of today. Of course, Poe was wrong in many details, and he didn't even dare to imagine a universe where there is no time at all, as scientists do today. As physicist Sean Carroll says, time, a thing that is so important to us every day in ordinary life, disappears the deeper we delve into the laws of nature. We see no signs of it where the foundations of our reality lie. Einstein said that the past, present, and future are only an illusion, albeit a very persistent one. After all, a single, absolute time for the universe is impossible. This follows from one of the most tested theories in physics today, the special theory of relativity. The same event happens at different times for observers in different places. So, the star you are looking at now is already gone, but its light continues to travel to us. And for us, it is still alive. What kind of simultaneity can we talk about in such a huge universe? But it's not about size. We can't even say what exactly is happening right now on Mars. It's 20 light minutes away from us. That is, we always see it in the past, as it was 20 minutes ago, because nothing can get there from here or from there to us. No image, no information, faster than the speed of light, sooner than in 20 minutes. It turns out that each of us is trapped inside each separate, specific instant, like that ball at each specific point in space-time. After all, we measure any movement relative to something, and everything that is not us is not simultaneous with where we are. We are just easily deceived by the feeling of simultaneity when looking at an apple, because it's too close for us to realize the delay in receiving its image. And I'm not even talking about the processing time by our brain. So even the apple in front of us, we always see in the past because we are at different points in space-time. This is a direct consequence, I repeat, of one of the most tested, and in this sense, reliable physical theories in all of history, the special theory of relativity. It turns out that the past, present, and future, from a physical point of view, really just don't make sense because all events are presented at once in the limited capacity of the universe called space-time. It's just that we can't get out and walk around like in a library between the shelves to look at the rows of events from the side, because movement is a change of point in both space and time. Unless we are gods, of course, capable of being outside of reality, you can't leave time without leaving space. This concept of the universe as a block whole, unified and simultaneous, where everything is already manifest, is called Eternalism, from the Latin eternus, eternal. And it has its weak points, despite such powerful scientific support. Interestingly, few physicists argue against it. It's mostly philosophers, but physicist Lee Smolin, a respected and persistent man, wrote a whole book called Time Reborn. In it, he writes that if we agree that we live in such a unified, timeless universe, then we are forced to accept that the laws of nature, as we see them in our now, have always been this way, and this prevents us from finding out how we ended up with the very universe we have. And there might also be a contradiction with quantum mechanics. You know, while I was preparing this material, I kept coming back to the thought, what does this mean for understanding what we do? For us, time is real, even if as an illusion. We live, our whole civilization is built on the idea of time. And what if, at the same time, we are actually like in a movie that has already been filmed, and we are just watching it, and that's all that's left for us? Even the decision to do something unexpected, contrary to the plot, will be part of the plot. This very rebellion against predetermination is just another episode in the script. For people, let's say, more inclined than many of you to a mystical worldview, not even with a glance, but with an irrational feeling, all this would mean what others turn to blind faith for, that all those who are no longer with us are alive. Not with us, but alive in a sense, like actors we see in old films and remember only because we watch them. And one might think that we will be alive even if no films are made about us, or videos with us disappear along with YouTube, because we will be in the film of reality. This is a slippery, unscientific thought, of course, because if they are alive, it's not at all in the sense of eternal life, of non-dying souls with whom one can even communicate, as some religions permit. This thought seems so similar to a religious one, only because of the metaphors and simplifications that scientists, and I after them, use to talk about what is happening in the physico-mathematical formulas describing our reality and its nature. But the more I talk about science, the more I realize that our mind, if it understands anything, often does so because it is fueled not only by the rational. There is nothing terrible in dreams, as long as we don't confuse them with reality. And at least sometimes, a little naively, or on the contrary, desperately boldly, we imagine, what if? Splex.